I'm going to try something different today. You can see my face is in the bottom of the screen. We are going to actually do something where I've already recorded. The main. Um, I've already recorded the video, but I'm going to record over it I'm voice overing it. But you'll see that you can see everything I'm writing, and I'll talk over what I'm doing. So let's go ahead and start this and see this looks like. So the application, the lesson today is on applying exponential equations, and we're going to start with example 1 here. Now I want you to realize when I talk about this example that that all these problems are going to be word problems. They're all going to have formulas involved in them. So in this problem, it says a typical credit card company charges 18% annual interest, compounded monthly on the unpaid balance. If your current balance is $520 and you do not make any payments for 6 months, how much will you owe? So this, this particular problem uses this formula up here. This A equals P times 1 plus R to the T, where P is the principal, R is the rate, and T is the time. Now, I want you to realize that this is complex. It's not quite as simple as it seems. They charge 18% annual interest, but it's compounded monthly, which means that we have to account for the fact that every month they're actually charging interest. So the rate is going to be divided by monthly rate. So let's look at the formula. So the amount equals 520, which is my principal, times 1, oops, I messed up there, 1 plus the rate, which is 18%. Now, when I do this, it's 18% divided by 12. Now, the reason it's divided by 12 is because I'm compounding it monthly, which means that I have to account for each of my my monthly amount. So it's 18% divided by 12 because I'm doing it every month. The time is how often am I doing it? I'm doing it for 6 months. So it's 18%, which is my yearly rate, divided by 12, so that it does it monthly for 6 months. And then I will pop that into my calculator. I guess I wrote on here to talk about the fact that we just talked about that 12 months, okay, in a year, which is why we divide it by 12. So, and I pop that in my calculator, end up with an answer, which is underneath my screen here. So my answer is, there are some technical difficulties, but I think I'm going to like this better. It's 568.59. We can go back a little bit here so we can see this. Okay. Oops. Now it's rewinding too fast. So here we'll see it. It's 568.59. All right, the practice problem. Now I did skip forward and then go back, so we are going to pause when we get back there a second. The practice problem, there's a mistake there. Okay, so I want you to notice this practice problem when we talk about this, that when we talk about an annual rate, see if it's an annual interest rate of 6.4%, we don't have to divide the rate by anything. If it's quarterly, that's 4 times a year, we divide by 4, monthly we divide by 12, and daily we divide by 365. Now this is going to say, this is for 3 years, so every year we have to multiply by how often we're doing it. So for example, if we're doing it quarterly, we have to multiply 4 times 3. I messed up and put a formula in the middle of it. I didn't mean to do that. Here's your practice 1 solution. See if I can get rid of that. So here's example 2. Pause. Okay. So example 2 is exponential growth. So all of these, your problems on your homework are going to be following different formulas. So this is one of them. The formula for interest was the first one. So exponential growth uses this formula here. F of x equals P A to the x, where P is your principal, the initial quantity that you have. A is going to be your compounding factor. So how often does the quantity duplicate? And x is going to be the number of times that you're doing it. You could have, you notice this 1 plus r is a rate, but most of the time it's just a letter. All right, so let's go ahead and move forward with the problem. Maybe I'll write on here in just a moment. Okay, so the first question asks us to make a table showing the number of fruit flies present for the first 4 days. So if the fruit flies are tripling every day, I know that day 0, which is my starting point, is 200. So the next day I have 600, 200 times 3. 600 times 3 is 1800. 1800 times 3 is 5400. And 5400 times 3 is 16,200. Now I'm going to write a formula for my function, with P being my amount, A being the compounding factor, and X being the rate, or how many times I'm doing it. I don't know how many days. This is just a formula. So I'm tripling, so it's 3. All right, so the growth factor here is 3. To find the next 7 days, a week from now, which that got cut off, I apologize, it's 200 times 3 to the 7th, which equals 437,000 fruit flies. That's a lot of fruit flies. Let's hope some of them die. All right, exponential growth with bacteria. This is your practice problem. And then you'll go to your solution in just a moment. There's your solution. And now we will go on to example 3, radioactive decay. So this is half-life. This is actually an interesting problem because we're gonna talk about what happens. How do we date things? And it uses this half-life formula. So it's the amount times 0.5 to the x, which is whatever time we're looking for, divided by h, which is our half-life. So if the half-life of radium is 1620 years, that's going to be our denominator, and whatever it is, x years, will be our numerator. So I should have written that on there by now, 100 times 0.5 to the x over h. I must have gotten distracted at some point. There we go, x over 1620. All right, now, the next question asks me to find how much is left after 800 years, 1600 years, and 3200 years. Now, I want you to notice if it's half-life, and when I double that number of years at 3200, I should be left with, at the normal, at 1600, I should be left with half of the amount. I simply plug the numbers in and calculator it. This is actually really simple stuff if you use your formulas. The next one is 100 times 0.5 to the 1600 over 1620. Now this should be just about half. If I put in my calculator, I get 50.4, so it's really, really close. The next one is 100 times 0.5 to the 3200 over 1620, which gives me 70, or sorry, I was messed up when I was saying it, 25. Okay, now here's your practice problem, okay, half-life, and there's your solution, and that is the end of our video. Pause this, let me stop it. Using a new program, it's a little different.